Hello there, how's it going? My name is Mr. Ericart, and today we are going to be talking about a second grade physical science lesson plan that you can use in your classroom. So, the standard that I use for this lesson is 2-PS1-4, matter and its interactions, which is to construct an argument with evidence that some changes caused by heating or cooling can be reversed and some cannot. So some big questions that we'll look at in this lesson is what happens when substances are heated and cooled? Do all substances react to heating and cooling in the same way? Can these changes be reversed? Why would this be an important thing to know? How can we use this information to make decisions about which substances are best for certain applications? Some prior knowledge that students can learn to know about this lesson is that substances that are heated or cooled may change, and these changes can be observed. These changes can sometimes be reversed, and sometimes they cannot. Before we choose a substance for a particular application, it is important to know how substances are affected by heating and cooling. Some skills that the students will gain from this lesson are that scientists search for cause and effect relationships to explain natural events. In this lesson, we can observe whether or not a substance is changed by heating and cooling and use these observations as evidence to construct arguments about whether some changes caused by heating or cooling can be reversed. These arguments can be used to decide which substance to choose for different applications. In this activity, students will be developing their understanding of the concept of cause and effect in relation to matter and its interactions. So, the student learning goal for this lesson is that students will be able to observe simple heating and cooling experiments and use evidence from these experiments to construct an argument that some changes caused by heating and cooling can be reversed and some cannot. These arguments will be used to construct arguments about which substances are best for certain applications. The student social emotional goal is that students will accept the challenges associated with these science concepts and adapt their framework to reconcile misconceptions about the concepts. Students will use self-regulation to participate in the experiment and collaborate with peers in a respectful and constructive manner. Students will ask questions when clarification is needed and show a willingness to explore and investigate. Students will participate in academic discourse and use subject-specific vocabulary appropriately to facilitate in peer scaffolding and build subject-specific vocabulary. So some barriers to learning may be that several students in this class will face barriers to learning, and these barriers must be addressed in order to ensure that all students can access and comprehend this material. In the class, we have 3 LLL students. These students may have difficulty understanding a Tier 3 subject-specific vocabulary words, which will decrease their ability to develop basic foundational comprehension and higher-order thinking. Care must be given to create a vocabulary-rich learning environment, which can include visual aids and employment of science journals and discussion for academic discourse. 2 students in this class have IEPs. One has been diagnosed with mild autism, and the other has ADHD, learning disabilities. These students may find it difficult to access the concepts in this activity and may find it difficult to engage in collaboration experiments and discussions. Special attention must be given to ensure that the lesson is designed with student goals in mind. Implementing UDL principles will make this activity more inclusive, and expectations for learning must be tailored for each individual student to ensure that goals match abilities. Some common misconceptions are that students may also believe that heat and cold are substances, instead of understanding that heat is kinetic energy and cold is an absence of heat. Students may also think that substances are sources of heat and cold, instead of understanding that heat is energy and heating and cooling objects represents energy moving into and out of these substances. This movement of energy results in a change in the kinetic energy of particles within the material. Students can be confused about the reversibility of heating and cooling. Students may assume that because some substances, like water, remain the same after heating and cooling, the effects of heating and cooling are also reversible in other substances. Okay. So, some technologies I would use in this lesson. As a teacher, I would use a projector for the introductory video. And for students, they would use Chromebooks for graphic organizers, if needed for an adaptation for writing, and for Google Form exit tickets. Some academic language words that the students will be going over are heating, cooling, substance, reversibility, permanent, observe, construct, evidence, argument, and application. Some sentence framers for the students are, for emerging, we have substances can be heated or cooled. For expanding, we have some substances are permanently changed by heating and cooling, while in other substances, these changes can be reversed. For bridging, we have after observing data from my experiment on heating and cooling substances, I came to conclusion that some substances are permanently changed by heating and cooling, and some are not. I can use evidence from my experiment as evidence to construct an argument which substances may be appropriate for certain applications. So, next, let's talk about what I would do in the classroom. So I'm going to go over the day one of how my learning map would play out in the classroom. So I'll have an introduction that's about 10 minutes, and the teacher, myself, will play the irreversible changes video for the class and provide students with the phenomenon to explore and investigate. In a class discussion, students will ask and answer questions related to the phenomenon from the teacher, will provide prompts and model scientific inquiry and academic discourse with new vocabulary terms. That will take about 10 minutes to go over that, and then we'll do an experiment, which will be about 15 minutes in the class. And the experiment will go like this. After the teacher provides explicit instruction for the activity, students will work in pairs to conduct a simple student-directed experiment with 5 different types of candies and record these observations on a worksheet. Teacher monitors and checks for understanding. And for the next 15 minutes, we will do an explanation and elaboration part of the lesson, which the students will be using their observations, and students will complete a cause mechanism effect graphic organizer, and students will use their observations and explanations to create an itemized list of candies from most favorite to least favorite to ship. Teacher monitors and checks for understanding. Next will be a 15-minute discussion, and in a whole class discussion, students will share their list and provide justification for their reasoning. Teacher monitors and checks for understanding. And then they'll have an assessment that would be about 5 minutes, and the students will complete a Google Form self-assessment survey. The materials I will use is a laptop and a projector, 5 types of candies, a cooler, hot water, Tupperware container, Ziploc bags, styrofoam plates, pencils, observation, worksheets, cause mechanism effect, graphic organizer worksheets, and Chromebooks. So this is how I will assess student learning with informal assessments. The teacher observations about prior knowledge and misconceptions can be observed and addressed during the introductory discussion. During the experiment, the teacher can assess students' scientific thinking about engagement and questioning during the experiment. The teacher can assess a student's ability to construct arguments with evidence and justify their reasoning during the whole class explanatory discussion. Some student self-assessments are students will answer the following self-assessment exit ticket questions on the Google Forms. On a scale of 1 to 10, how interesting did you find this activity? On a scale of 1 to 10, how well do you think you could teach this activity? Which parts of this activity would you like to learn more about? Which ideas or concepts from this activity are you still confused about? Do you believe you tried your best during this activity? Explain your answer. And some formal assessments is that from the experiment, the teacher can conduct formal assessments of student ability to record observations from their observation worksheets. The cause mechanism effect graphic organizers can also serve as a formal assessment of students' ability to express their ideas with appropriate scientific language. The students' itemized lists and written justifications for their reasoning provides a formal assessment of student abilities to draw reasonably conclusions from evidence and communicate their understandings to others. This allows the teacher to assess the student's ability to construct arguments with evidence and justify their reasoning during the whole class explanatory discussion. And that is a little bit about the lesson plan and how I will dive into that into the beginning. And if you have any more questions, please let me know, and I would be happy to share with you how I did this in the classroom. Thank you.